So today we're going to have our Kaggle Grand Master, Guanshuo Xu, who's going to talk about his winning competition. Okay, you should want to go start.
Okay, so thank you for coming. Recently, I attended a Kaggle competition. It's LLM-related competition. The title is LLM Detect AI-Generated Text and Identify which essay was written by a large language model. And I got second place. And so today I'm going to present my solution to this competition. Let's first look at the problem description. So given an essay, we are asked to build a model to do binary classification to say if it is student written or LLM generated. So it's just a basic binary classification problem. And the metric used is also the classic AUC. And so before we continue, I would like to mention that I may use those terms interchangeably during the presentation. So for negative class, I may also say student written or human written or class 0. For positive class, I may say LLM generated, AI generated, or class 1. So let's talk about the data set. So in this competition, in the test data, which is also the leaderboard data set, we have totally 5 essay topics or titles and totally 9,000 essays all generated from those 5 topics. And they are both student written and all LLM written. So there's both of the 2 class data in the test data. So, and our job is to build a classifier for them. And for the training data, we have around 8,800 student essays. Those are the negative data, and they are from the same 5 essay topics. So in this competition for the training data, we are only given negative data point. So to build a binary classifier, we need to create positive data by ourselves. And we will use LLMs to create data. So before we dive into the solution, I'm going to first talk about the difficulties in modeling for this competition. So the first issue is since we are to generate positive data by ourselves, and when we generate data using LLMs, we need to give prompt, of course, and we need to choose which LLM backbone we are going to use, and also we need to set generation hyperparameters and possibly do some post-processing. The thing is, the organizer didn't tell us how they exactly set all those stuff or choose all those stuff. So there must be a distribution difference between our own generated and the organizer generated data. So which means the local validation on the data set created by ourselves may not work. That's the first issue. The second issue is later during the competition, we got information that private and public data, leaderboard data are split by the essay topics. So since we have totally 5 essay topics, I think I remember 2 is set for public leaderboard and 3 is set for private leaderboard. The thing is, there are only totally 5 essay topics. They are too few. So if there are, let's say, 2,000 in public or 3,000 in private, it should be fine. But since there are only 5, and they are very different, so there could be a distribution difference from public and private leaderboard, which means if we overly rely on the public leaderboard as validation set, we may overfit to the public leaderboard, and performance will drop on the private leaderboard. So that's the second problem. And the third issue is similarly, we only have, there are 9,000 test data, which is not that small, but they are generated by the 5 essay topics. So there's strong correlation between data. And which means if we somehow translate into IAD data, the data set is should be much smaller than the 9,000 test data, which means this is another risk of validation on public leaderboard. So since we have all these 3 difficulties, I believe that this is a rare Kaggle competition, that strategy could be more important than validation. So let's talk about my solution. So for the classifier, I simply use the DBERTA model as default. So just for simplicity, we can also choose a much larger LLM-based classifier, but they're just much slower to train and also slower for inference. So I believe DBERTA is good enough for this competition. And usually, when we how do we solve this binary classification problem? So given we already have the model pre-trained on that is good on general language, and what we can do is we can generate data set and simply do a fine tuning, which is the second step. That's the usual way we solve this problem. But in this competition, I add one extra step, which I call it's a pre-training step. So the purpose of it is to move the general language model to the competition problem domain, so that we will have more chance to get a better final model after the second step, the fine-tuning step. And this pre-training step can also alleviate the issue caused by distribution difference, because in the second step, the transfer learning will rely on less of the in-domain data. So after that, we can do the usual fine-tuning step on those essay topics to move it even closer to the leaderboard data set. And I would like to emphasize that in this competition, I only focus on the data generation of these 2 stages, the pre-training and the fine-tuning stages. So which means that those are the data we use to train our DBERTA model. But the actual fine-tuning on the DBERTA model, I will not talk about it because it's so, so basic. So let's talk about the pre-training. So what I did was I used a slim pajama dataset, and this is a dataset that I think it's commonly used to train large language models. And I randomly select about 500,000 documents from this dataset. And for each document, I randomly set a truncation point and use the text before the truncation point as prompt and ask the LLM to complete the text. So this way, the LLM completed text will become the positive data, and the original one after the truncation point will be the negative data. So I have to say that I'm not the inventor of this approach. Some other Kaggle called James Day, he published this method sometimes before I think maybe 3 weeks before the competition end, and because at that time the Kaggle, the competitors, they believe that transformers, those big language models, they don't perform as well as some traditional methods like TF, IDF in this competition. So he simply showed us one way to perform well using the transformer model on the leaderboard. So it,
Oh, sorry. You mentioned that you generated the rest of the prompt through LLM. So
yes,
did you use like some publicly available LLM?
yes.
Okay.
I'll share later.
Okay. Okay.
It's in the later slides. So this is a very creative approach, and I was also excited when I see his post, and I personally believe that this approach is best not used for the final model, but as a pre-training step. So I simply used his approach as a pre-training step. So let's take a look at some generated examples. So this is a random pick of the data, and we see it's talking about some NBA players. On the left is the origin text we use as a prompt, and we can see that in the end, we see that West reached a point where he just wanted to win an NBA championship, so he signed with the San Antonio Spurs. And so after this end, this is the truncation point. And on the right side, you can see human. That's the origin test. So the San Antonio Spurs and later the Warriors as a warrior. So that's the original test. And in the middle is the LLM generated text, and won the 2018 NBA championships there. So it looks pretty good. I mean, the generation, but it might not be true. So, but it's okay. We're not talking about the actual facts of the text in this competition. So the AI generated or the LLM generated in the middle, we serve as a positive example, and on the right is the negative example. So another example, let's see. It's talking about some energy saving program. So similar, I just showing it so you got some idea. And there's sometimes these are just references, and the LLMs are able to complete it with adding some other references. So what is good about this pre-training approach? So this pre-training approach simulate the process of essay writing. So we remember that we use the first part as the prompt, and the second part as the second. So we asked LLM to complete the second part. This is similar to giving a title or some instruction for a student to write an essay, and the student just complete the essay. So the process is similar. That's why I think it's a very smart approach. And since we are randomly picking from a very large public data set, there's no risk of overfitting to any types of prompts. And we have endless number of training data in this way. So after this pre-training step, the model has become a general model in the problem domain. So in the problem domain, I mean, it's already quite in the competition domain. So it's much closer compare with the originally pre-trained DBERTA model, much better. So in total, I used totally 15 LLMs. Most of them are 7 billion or smaller. And I find that 7 billion is a sweet point as a very good balance for efficiency and performance. So after the fine-tuning, after the pre-training step, we can then do the fine-tuning step. So still, I'm going to talk about the data generation, because we need to still need to generate positive essays, LLM generated essays for this fine tuning step, and we are only given the student written essays. So we can see two examples from the 5 topics. You can see on the left, topic title, the face on Mars. On the right, exploring Venus. And on the left, the assignment that you have read the article, Unmasking the Face on Mars. So this unmasking the face on Mars is some, they say this is some source text that's or some article that students need to read before writing. So you can see that using the information in the article, write an argumentative essay, blah, blah. So the students are actually required to write an essay based on the article. And just showing the student the assignment or the topic is not enough. So, but the problem is, we don't, those source texts or articles, we don't have access to them. At least we cannot freely get them from the internet. And the organizer did not provide them. So this could be an issue. Why?
So for those 2 topics, there are no student written essays out of the 8,800.
Yeah, there are student written essays.
But the source is not, the essay is there.
Oh,
but
there's
the-
no source.
Oh,
Yeah,
okay.
yeah.
All right, got it.
But students write. I mean, they wrote based on the source text. So I'll show you example later. So why is this a problem? Because in the dataset description, you also say the organizer say in each prompt, the students were instructed to read one or more source texts and then write a response. So the students have access to those source texts. And the same information may or may not have been provided as an input to the NLM when generating an essay. So may or may not. So the information may be provided as it. So I guess that part of the data set, I mean, generated as data set, they provide such kind of information. And the thing is, if we don't have those articles or source text, the LLM generated data set will be too easy to classify because all the negative data, student written text, they are all based on those articles. But the LLMs, none of them are generated, none of them are based on the articles. So you can simply use the content of the text for classification. And of course, we will get a good result, local result, if we do it this way, but it won't translate to public leaderboard or private leaderboard because the organizer actually have those texts when generating essay. So let's see a example of the student essay. We can see that in the yellow marks, you can see that those are the original text the student are either citing or quoting. In 1976, the Viking took. So these are the original text, apparently. And we can also see some spell and grammatical errors marked in green. So we don't have access to those articles. How to solve this problem? So since we can't feed the original article to the LLM or the source text to the LLM for generation, we can do it in indirect. Because when assume that we're human being, we read a lot of student essays written based on those articles, and we can already get an idea about what is in the articles, because the students will frequently cite and quote, and you can get information from it. So I inspired by this, we can continue language model fine tuning on for the LLM on the student essay. so that the LLMs will have an idea. The LLMs will learn to mimic student writing and start citing and quoting as if they have read the article. So to do this language model fine-tuning step, I use H2O LLM Studio, and it's open source. The hyperparameters are very complete for LLM training or fine-tuning, and there's no need to write code. So the first step is to create a CSV file as a dataset file for language modeling. And in the file, we have two columns. The first one is we use the assignment, which is, let me go back. Yeah, I use the assignment as the prompt, and the actual student essay as the something like the answer. So it's similar to question answering. And the next step is to download and install H2O LLM Studio, of course. And once we start the LLM Studio, we can import our prepared CSV file into the import dataset. And
How big is that data set?
how big is the dataset? It's it's 9,000, around 9,000. I input every of the provided student.
Oh, okay. You used all the training set from
Yeah,
Kaggle.
all the trainings,
Okay.
they are all negative sets. So after that, we can create experiments and pick the data set, of course, and the problem type is just the most common causal language modeling. And we also can choose our favorite backbone, LM. So with this LM Studio, we can tune we can easily set the prompt length and the answer length and total length, and we can also set the backbone data type, and also the batch size, which we should use a batch size that fit our GPU. And for epochs, I only chose to let the LLM run one epoch because I don't want the LLM to overtrain, so it may forget its original ability, text generation ability, but only memorize the student essays. So that's why I only run one epoch. So there are also settings for LoRa. And after those setup, we can run the experiments. Once the training is done, we can select the completed experiment. And in the bottom, then we can download the model. So after download the model, we can use it the same way as other LLMs. So it's pretty straightforward. So the LLMs I use for this step, for this data generation, I use some Llama and Mistral model. Using more models may be helpful, but at that time I was running out of time, so I only used, I think these are the most common LLMs. And then I can start batch generation. And so totally, I generated around 18,000 positive samples. And when doing the generation, to increase the diversity, I set temperature to multiple values. So this is the example of the generate text. We can see that the LLM can, similar to students, they can start citing and quoting the original text, marking yellow. and without provide, we don't even need to provide the original article. And also interesting, another interesting thing is the LLM start more frequently, I mean, create spelling errors. And so, so I think it's good for the final classifier because the final classifier won't rely too much on those spell errors as an artifact.
You still have the problem of all the human generated labels have same topics.
Yes, yes, same topics. So when I do generation, I did the same way as when I prepared the CSV file. So just input ACID, just provide an assignment, and there I'm generating ACID.
Yeah. Would it be more, would the model be more diverse, classifier be more diverse if you generated that 18,000 from topics that are not already one of those 5 topics?
Yeah, but in this case, because those those topics are not included in the leaderboard, so it's
Okay.
from different distributions. So
Okay.
it's better not include them because we already have after the first pre-training step, we already have a very general, very good model. It's a general model in the open domain, I mean. So after we generated text, we can do the fine tuning, and in this competition, I trained two dBeta V3 models and one dBeta large model. So totally we have 3 models, and we can do fine tuning on the our generated text. We have around 9,000 negatives and 18,000 positives. Since some other competitors very generously share their generated data set, so I also fit the same 3 model on their data set, and also blend them into the ensemble. So totally we have 6 models. And we can see that on the right in the table, in the right bottom of the table, the 6th brand scored 0.9834, which is which made me rank 2nd. So in summary, we have 2 key steps in my solution. One is the pre-training step, and the other is the fine-tuning step. And after the competition, I was curious of the importance of these 2 steps. So I applied them independently. So if we can see the right side of the figure, which is the private leaderboard. And if we only do the pre-training step and use the model for the final competition result, we can rank number 8, which is quite surprising to me because it's top 10 performance, and we haven't used any of the in-sample in-domain data set provided by the competition host yet. So it's pretty surprising. And if we only do the fine-tuning step, which is obviously, this is obviously more important because it directly works on the in-domain data set. We can get 0.97, which will rank us number 5 in the private leaderboard. And if we combine these 2, it will be ranked number 2. So that's all of my solution. Thank you for listening. So any more questions?
Any more questions, guys? Oh,
Thank you, Guanshuo. But a question like, what hardware did you use? Did you use like your on-prem hardware, or are you going with the fine-tuning, pre-training to the Amazon or any?
I use my own hardware.
Okay. Okay, like stuff like 4090s.
It's I have three A6000 RTX A6000.
Okay, nice, nice.
Yes.
And if you look back, what would you change? Like you mentioned that you didn't have enough time at the end to do like generate more samples. So is there anything what we would
Yeah, I
change?
will definitely try. Because when we do the let's say in the first step, pre-training step, we use 15 LLMs, but all those LLMs is not. I mean, they are not. They're around 7 billion. So I would probably use larger LLMs for higher quality data, but it will take a lot more time. Also, I may play with some hyperparameters during, for example, temperatures or top K, top N, those stuff to increase diversity. And for the second step, I will probably also include more. I only use 5 LLMs, so we'll probably use even more to generate more data. And in the final fine tuning I mean, the model I use as a classifier, I only use I only use the Berta model. But I'm also interested in the performance of LLMs as classifiers. But I didn't have a chance to try because it would be taking too long. So I'm not sure about that.
And did you also compare with the first place, like the first solution? There was like, what was the
Yeah, the
difference?
first place, I think it was it has much more content. They seem to build more diverse models. I'm not sure how to compare with them because my solution, I'm a solo player, so I was a solo player in this competition. So my solution is relatively more straightforward. So I don't know how to compare with a solution that with a lot more ensemble or different approaches combining with my approach.
Yeah, I just want to clarify some things. The first 15 LLMs you had,
Hmm.
they generated only LLM generated text, right? So they're positive. Positive is LLM generated, correct? Positive examples.
Yes.
So this 15 only generated the positive set.
Yes.
And
Because the negative set is the original text.
yeah,
So we can directly use.
so this positive set is that completion. So when you deleted some of the articles and then from the slim pajama set, or did these positive examples also like had created the essays?
It's all
The-
from this slip pajama data set.
Yeah. So all the positive examples, how many of them? 18,000?
No, it's 500,000. It's almost 500,000, around
Half a million?
Yeah, yeah.
So they're all generated by this 15 LLMs.
Yes.
That's all the positive examples you had,
Yes, for the pre-training step.
pre-training stuff.
Yes.
And then when you had the negative, you amplified the negative examples using the 5 LLMs that you got out of the LLM Studio.
For this step, I didn't use the essay text.
Yeah, this you use original human text as the negative examples
Yes.
for this stage.
Yes.
Okay, and the next stage, if you go to that slide, in the next stage, you call this the fine tuning stage, or
Yes.
okay, so this is fine tuning the DeBerta model.
Yes. So, okay, I mentioned before that
Yeah.
for both the fine tuning and the pre-training step in this competition, I mainly talk about the data generation because we need data to do the training, right?
Correct.
So the actual classification, the binary classification, I use the Berta model. That is very straightforward.
Yes.
So
Okay.
that's not difficult. So I don't present it here.
Okay. So I just want to know how many total positive and negative you had for the in the form of essays. So this 18,000 from these 5 models, these are all student generated negative examples, right?
These are positive examples. So student examples has size of around around 9,000. Yeah.
9,000.
Uh-huh.
Feed that into the LLM studio. So he has a prompt, the student generation, and he do the fine tuning such that the output from the LLM will be
Yeah.
derived from the student one.
No.
So all the grammatical error, all the spelling errors is there, right? And then
Yes,
use the
that's a problem, no? So 9,000 negative, you used all of them as is, and then 18,000 positives are coming from the 5 LLMs that are
Yes.
fine-tuned on the student content.
Yes.
Because now isn't the positives are also very close to the negatives that way?
Yes, that's the purpose of
That's the point of it? Okay,
that's the
so even when it is
yeah.
so close, you want your classifier to identify.
I want to make it more difficult
Okay.
because it's closer to the actual leaderboard data set. So
Okay.
that's why I did this step.
Okay.
So why do you think the results are better on the private leaderboard than the public leaderboard in this case?
Yeah, good observation. I don't know, to be honest. I don't know.
Was there
I'm
a
totally blind on
was there a
this.
difference in the data at all that you can tell, or is it it's hard to know?
Maybe because the prompts or the essay topics are very different. It could be from the different topics, or maybe there's some difference in the generation of, I mean, positive data generation of the public and private leaderboard. Only the host knows. I don't know, to be honest. Maybe not. Some of them just try to validate on the public leaderboard, so they might overfit it.
Can you see the results of the other competitors, like for their public leaderboard
Yes, I
ranking
can
and
see.
private?
Yeah, I can see it.
Oh, okay. Because we're kind of curious
Well,
if they have the big difference like you did. The result.
Yeah. That's true. That's why I mentioned. That's why I emphasize their the difficulty in modeling. You remember?
It's like a distinct effort to not overtrain on the public data resulted in the improvement on the private data, I guess. But
Yeah, exactly.
yeah.
So I have showed the difficulty of the modeling that we can actually trust neither of our local validation and the public leaderboard in this competition. So I didn't rely too much on the leaderboard or validation. So it's more of using intuition.
It's very nice. I just have a couple questions, 2 questions. One is that do you have some kind of criteria in terms of how you choose those models? The 15 and the 6. And then the other question is about the H2O LM studio. When you do the fine tuning, how long does it take for sort of?
So for the
Roughly.
second question, for 7 billion models, I think on my machine it took around an hour to finish the fine tuning for one 7 billion model, and maybe 2 or 3 hours for the 13 billion. And for the first question, and I really because how do I select? I think I have looked at many of the LLMs, and I chose to use those that I think I for some of them I picked using the Hugging Face open leaderboard.
The ranking.
Yeah, the ranking based on the ranking, but I also care about. I think I mainly focus on smaller models, because I don't think I have much more choice. But of course, there are so many versions of LLMs, and so if we increase the number of the LLMs used, probably we can do better. So yeah, I just, for the first step, these are just the LLMs I use, and they are all open source. So I picked them. And for the second stage, those 5 LLMs are all I mean, by default. They are all the like default settings in LLM Studio. So that's why I give priority to them. But I certainly want to add more, but I didn't have time for that.
Number one ranking show what kind of models they use and
Yeah, for classifier, for LLMs, I don't remember, to be honest. But for classifier, they did use LLMs for classification, but I only use debata. So probably, yeah, that's one place I can improve. But for LLMs, I don't remember.
Okay, anything else? Anybody else questions? All right, if not, thank you for the presentation. Thank you for the questions. Thank you for you guys to come. If you want to know more information about H2O LLM Studio, please go to our website. It's in the App Store, right? Gen AI App Store. So try it out.